Welcome to today's webinar brought to you by OpenText. I'm Stephen Fegg, Director at Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Stop Fixing, Start Predicting, Mastering Predictive Maintenance with IoT Data Analytics and AI. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Now, to introduce our speakers for today, we're very excited to have with us Phil Schwarz, Industry Strategist for Energy and Resources at OpenText, Ryan Sickles, Lead Product Manager, Core Analytics Database at OpenText, and Virgil Dodson, Product Marketing Director of Analytics Cloud at OpenText. Each speaker today is going to give a brief presentation, and then we're going to dive into a group discussion. So without further ado, I'm going to pass the event over to Phil to get us started. Welcome to the broadcast, Phil.
Great. Thanks, Stephen. And hello, everyone out there. Hello from Alaska. For those that are unfamiliar with OpenText, I'd like just to do a quick introduction of our company. We're the global leader in the information management software domain. Gartner defines this technology domain as a method to collect, process, and condense information with the goal of efficient management. And how OpenText executes to the spirit of that definition is that we organize, connect, automate, and protect data to elevate human potential. We serve a variety of industries with the most complex information challenges, including financial services, public sector, energy and resources, the industry that I support, manufacturing, healthcare and life sciences, and many others. The world of information management is already opening up new possibilities, and predictive maintenance being one of them in the focus of today's webinar. As we move to a world of autonomous decisions, we're inspired to reimagine what information can really do. Information is any important data at any stage processed by humans or machines. And reimagine is to think about something in a completely different way, like maintenance of assets. At OpenText, we make information management software to help customers reimagine what they can do with their information as they modernize their work, shown at the top of the cycle, and moving around clockwise, connecting business fabrics. I'll speak to this business unit briefly in a couple slides, which plays a key role in predictive maintenance. Deliver digital experiences, advance their developers, embed security everywhere, automate infrastructure and applications, and optimize decision-making, which includes our AI and analytic capabilities that power predictive maintenance. The OpenText Cloud, shown in the center of the graphic, is our portfolio of offerings and is here to serve the future knowledge worker. This means that everything we do has AI, security, and information governance around it. And this enables OpenText to uniquely bring to our customers trusted information with governance over large data sets, next-generation autonomous cloud, utilizing software to minimize human error and manual work, and AI and security everywhere at scale with enterprise strength. This is information reimagined. All right, so we're in an era where data, AI, and IoT are transforming business. AI and machine learning are everywhere, driving operations, using IoT data to optimize production and customer experiences. Shown in the middle, conversational data and democratization means that insights are now accessible to everyone. From technicians and field engineers, like I once was, to executives, IoT-driven insights are available in real time, breaking down silos and enabling faster decisions across the organization. And finally, on the right, the fusion of predictive and prescriptive analytics is a game changer. IoT data helps us predict issues, and prescriptive analytics tells us how to act. This empowers organizations to be proactive, prevent disruptions, and enhance efficiency. All right. So as a former field engineer in the energy sector, I've invested over 2 decades of my career supporting critical assets. And I've personally felt the pain and challenges that come with reactive maintenance and servicing critical equipment and assets that cannot go down. For far too long, businesses have been running a race against time when it comes to equipment maintenance. Whether it's a manufacturing plant, a fleet of delivery trucks on the road, or life-saving medical equipment in a hospital, downtime means one thing: loss of productivity, loss of revenue, and in some cases, even loss of life. Reactive maintenance, where companies wait until something breaks, has been a traditional approach, but it's a costly one. Unplanned downtime costs industrial manufacturers alone $50 billion annually, and the average company loses 5% of its productive capacity each year. But what if we could be smarter and reimagine a better way? What if machines themselves could tell us, I'm not feeling well, or I need maintenance, but not yet? What if we could fix problems before they happen at the least disruptive time, and with everything that we need already prepared, optimizing performance and minimizing costs? So this is where predictive and prescriptive maintenance comes in. Predictive maintenance uses advanced analytics and machine learning to forecast equipment failures based on real-time IoT sensor data, allowing you to plan repairs ahead of time and reduce downtime by 30 to 50%, estimated by McKinsey. Prescriptive maintenance goes further, not only predicting failures, but recommending how to prevent them. Whether it's by adjusting machine settings, ordering parts, or scheduling technicians, this approach optimizes maintenance scheduling, delivering 20 to 30% cost savings estimated by PwC. Overall, predictive maintenance offers a tenfold ROI, transforming maintenance from a reactive burden into a strategic advantage. It keeps operations running smoothly, whether in factories, hospitals, or power plants, resulting in happier employees, satisfied customers, and better shareholder returns. Now, just to wrap up here, remote monitoring of equipment performance, shown in the box in the upper left, implies securely connecting equipment data across and outside your enterprise. Securely connecting B2B business fabrics, which includes IoT, is one of our largest business units and areas, especially within OpenText that I highlighted earlier. For the sake of this webinar, we're going to focus on the predictive and prescriptive maintenance aspects using AI and analytics. So with that, Virgil, if you take us through some of the technical challenges that companies come to OpenText to help them overcome.
Sure, Phil. So you might be thinking, this sounds too good to be true. And if so, why doesn't everyone do this? So while the promise of predictive and prescriptive maintenance is lucrative, the path to getting there is challenging. We're talking about a massive scales of data, a deluge of information that's generated every second by thousands of sensors across hundreds of machines. And the challenge isn't just collecting the data, but making sense of it. How do you sift through millions of data points in real time, find the patterns that match, predict when a failure is likely, and then recommend a course of action, all without overwhelming your IT infrastructure or exhausting your budget and staff? So first is the issue of data integration. Companies are often dealing with massive streams of data coming from various IoT sensors and systems. And without a unified approach, it can become difficult to process and generate actionable insights in real time. Next is a question of scalability. When you have hundreds or even thousands of assets producing millions of data points, traditional systems can struggle to keep up, making it hard to analyze data at scale effectively. Latency is another challenge, and to truly prevent failures, we need to act in real time. But many systems rely on batch processing, which can introduce delays and reduce the accuracy of predictions. Another hurdle is the accuracy of predictive models. These models need to evolve continuously as equipment and conditions change, but ensuring their accuracy without manual intervention is a challenge. Infrastructure is also a common roadblock. Some organizations don't have the computing power or data architecture required to handle advanced analytics, which can slow down implementation. Finally, there's the growing concern about data security. And with IoT networks and predictive maintenance models, ensuring data privacy and protecting sensitive operational information is a top priority. So in predictive maintenance and IoT combined solution, developers and data science teams perform several key tasks to prepare data for the machine learning models. These tasks help ensure the data fed into machine learning models is accurate, relevant, and well-structured, leading to more reliable and effective predictive maintenance solutions. The skill sets in a typical organization can vary by team or even by day, so it's important to find a solution where people from various skill sets can work together. On the left side, you'll notice products listed that can perform each of these tasks. These also relate to a skill set. The OpenText Analytics Database, or Vertica, across the top can perform all these tasks using some very advanced SQL and AI modeling capabilities, and by design leans towards a more technical user. OpenText Data Discovery in the middle is designed for visual analysis and quick drag and drop capabilities, which means Not only can a technical user do something faster, a less technical user can also perform the task. And along the bottom, OpenText Intelligence or Magellan BI reporting brings in the enterprise sharing of these insights in the form of dashboards and reports. And the best part in this scenario, since each of these products are connected to the exact same database, you can mix or match based on your need at the moment. So data collection or integration is just like it sounds. It's gathering real-time data from various sensors and IoT devices, like collecting temperature, vibration, or pressure data from a machinery to monitor its health, and then combining that data with other sources to create a comprehensive data set. For example, merging real-time sensor data with historical maintenance records to provide context in a predictive model. Data cleaning and transformation involves identifying and correcting errors or inconsistencies in the data. For example, removing duplicate records or filling in missing values or normalizing sensor data. Feature engineering and selection is an important step and involves creating or identifying variables from existing data to better capture the underlying patterns. For instance, selecting features like vibration frequency and temperature spikes that you notice in the data and are strong indicators of equipment failure. Exploratory data analysis involves visualizing and analyzing the data to understand its structure and relationships. This might involve plotting sensor data over time or using pre-built models such as outlier detection and pattern matching, making it easier to identify trends and anomalies. Or in data discovery's case, perform super fast visual ad hoc analysis using pre-built analysis like crosstabs, Venn diagrams, and profiles. Next, model deployment and model management includes model training and evaluation as well, and database machine learning, and lots of built-in machine learning functions, which together gives us the ability to run predictive and prescriptive models on the prepared data. Finally, on the right, in actions and scheduling, you would execute the recommendations and monitor the results workflow. You can also define automated actions or sequences of actions that can be executed on demand, event-based or scheduled. And if needed, the data can go out to self-service or scheduled reports and dashboards. So the predictive and prescriptive maintenance solution from OpenText promises to minimize disruptions by anticipating failures before they happen and involves several products that you see off to the right. The OpenText Analytics Database, or Vertica, is the embedded or analytical database providing the extreme scale to the solution, as well as powerful in-database machine learning and connections with the data science notebook. OpenText Data Discovery brings super fast visual ad hoc analysis and discovery, as well as drag-drop interface full of wizards and helpers for data cleansing, blending, and enrichment. And then OpenText Intelligence or Magellan BI reporting helps you get a complete picture of maintenance operations. And together, these become one solution for big data, analytics, and enterprise reporting. So you don't have to take our word for it. Let's see what a few customers have to say. We'll start with Philips Healthcare, a global leader in medical imaging systems like MRI and CT scanners. They were dealing with millions of events and 200,000 sensor readings per day across their machines. And unplanned downtime was a significant problem, disrupting clinical workflows and increasing operational costs. Philips needed a shift from reactive to data-driven proactive maintenance. So by implementing a predictive maintenance platform powered by Vertica, they processed 1.5 petabytes of data from over 200 sources, enabling proactive issue detection. The results? Philips achieved a 30% reduction in equipment downtime and boosted their first-time fix rate to 84%. Moreover, they were able to identify over 20% of issues before they were even impacted customers, ensuring better patient outcomes and reducing operational costs. Norbremse is a leader in braking systems. They needed to enhance their predictive maintenance capabilities across their fleet's complex systems like brakes, ventilation, and wipers, while meeting growing demands for self-service reporting as well. With OpenText Intelligence or Magellan BI reporting, they provided fleet operators with real-time diagnostics and predictive insights through embedded dashboards. This resulted in a 20% reduction in maintenance costs, extended the life of components, and improved their fleet safety through real-time data visualizations. This solution not only reduced downtime, but provided fleet operators with an ROI in around 2 to 4 years, making predictive maintenance both efficient and cost-effective. And Ritsu provides service assurance in the telecommunication industry. That is the continuous monitoring, management, and optimization of networks to ensure they meet the predefined service level agreements. And Ritsu has over 1 billion subscribers and is processing 80 billion rows of data every day. They needed a solution to implement predictive maintenance to prevent network issues and ensure infrastructure health, while also focusing on network planning and optimization for future growth. With OpenText Analytics Database, or Vertica, and Ritsu could analyze real-time data, predict prudential disruptions, and preemptively address network challenges. At the same time, they leverage predictive planning to scale efficiently without impacting service quality. The impact and Ritsu reduced storage requirements by 50%, achieved a 351% ROI, and had an astonishing 4-month payback period. Their ability to preemptively address network issues, plan for growth, and minimize operational costs showcases the power of predictive analytics when it's applied at scale. So at OpenText, our technology is not just theoretical solutions. They're already helping some of the most advanced companies in the world achieve operational excellence, not only in predictive maintenance strategies, but also in, advertising, finance, retail and e-commerce, software acceleration, customer insights, as well as IoT predictive maintenance. So with that, I'll pass it back to Stephen.
Thank you very much, Virgil, and thank you, Phil, as well, for those great presentations. Okay, so at this point in time, we're going to dive into our group discussion. To kick things off, Phil, companies to begin or advance their predictive maintenance journey?
Yeah, for the top trend that I see is we saw the pure cost of unplanned downtime, and that's a key trend. But since we already discussed it, to me, it's the pure number of machines that our daily lives rely on, whether those machines are in the public view or not. And the number of machines are growing significantly. There's so many machines out there that we rely on as humans, and so much that machines now generate 1 million times more information in one day than all humans on this planet do an entire year. So the quality of our life, the quality of our life depends on them, and the quality of our lives in the future will even more depend on them. Just as an example, in the energy and resources sector that I support, over the last decade, on average, there's been a 40 to 100% increase in gross plant property and equipment per employee. That can be validated by looking at any annual report for any asset owner. So what that means is that there are nearly as double the amount of machines that need to be managed per employee than a decade ago. And that trend will not just continue, but it will accelerate with the vast amount of capital expenditures being made in the energy sector alone. And that's just one example, but this trend impacts all industries that rely on machines, whether it's manufacturing, healthcare, transportation, and many, many more.
Understood. Virgil, are there some technology trends that you see driving this?
Sure. I mean, some of the obvious trends, but extremely important one, include things like artificial intelligence and machine learning, which enable us to be more accurate predictions. They can analyze crazy amounts of data that people just can't. As the number of machines grows, like Phil said, the number of IoT devices also is growing. So the more devices out there, the more opportunity for data. The digital twin, I think, is another trend as well. Being able to create digital replicas of these assets and allow you to do simulations and pretending, that you're changing different things to see what happens. Cloud computing, also being able to store massive amounts of this data as you're creating more data, you need a place to put it. And it can also collect from multiple places and multiple locations. There's innovations in the inspection tools, things like drones and more advanced sensors that can detect things that you can't see from the naked eye. And finally, big data analytics, being able to analyze this data, from a machine, helps us make better decisions faster and analyze both the historical record with the real-time data together to kind of predict future stuff as well is something machines and big data is really good at.
Understood. Phil, moving on, where is predictive maintenance currently being done? Is it at the equipment level, the system level? What are you seeing in this space?
Yeah, so I see two levels at which predictive maintenance is being done, and which we'll see further specialization in the years to come. Now, this is my views are through the lens as a former field engineer in the energy sector, and so first, I think the first level is at the equipment or device level, and that specialization for predictive maintenance is going to be led by the manufacturer or the field service provider maintaining or servicing that equipment. And the reason why I believe that is a given facility may have X number of devices of a given type or a model number, yet the manufacturer has an install base of tens of thousands or even millions, in the case of the manufacturers that I worked for, of that model number throughout the world. And so I think manufacturers and service providers will offer the most robust predictive models at the equipment or device level because of those vast install bases and being able to connect and capture that real-time data and build even more robust predictive models. Now, that may not be 100% the case, and there will always be special cases, yet generally speaking, through the lens I look through, the journey towards predictive maintenance at the equipment or device level will depend on strategic vendors with manufacturers and service vendors that offer predictive maintenance services and will strengthen the bonds between them and their customers, asset owners, and operators. The second area or level that I view that will specialize in predictive maintenance is at the facility or the process unit or the system level. And the reason why I believe that is every facility and its life cycle is unique. And the asset owners or facility owners know that collective facility best, and the interconnections and relations of performance of equipment on the performance on other equipment. And through the lens I look through, facility owners will specialize in predictive maintenance at that system level.
Understood. Another question, how has the predictive maintenance landscape changed? Or more broadly, how have maintenance operations changed?
Yeah, that's a good question. So many companies have begun their predictive maintenance journey, but many have not. And so no matter whether you're an asset owner, a manufacturer, a service provider, and your business relies on machine, whether it's operating them, maintaining them, repairing them, servicing them, you're either going to begin your predictive maintenance journey or make further advancements in your journey that you've already started. Because if not, there's a strong likelihood that your company will become irrelevant. And so no company is perfect at predicting and preventing failures that I know of today, but there's plenty of room for improvement. I think we're going to see a lot of progress in this area. Now, companies that manufacture the most complex and critical equipment today are well on their ways in their predictive maintenance journey. So, for example, jet engines. The manufacturers of jet engines no longer sell a jet engine per se. They sell a jet engine hours, and that comes with a guaranteed level of service in the SLAs. And meeting the terms of that SLA with the critical equipment that their customers depend on, it needs predictive maintenance because that critical equipment cannot fail. But it's that next layer down of critical equipment, whether it's control valves or instrumentation or motors or fleets of vehicles. I see predictive maintenance at that next level down, scaling over in the years to come. And I think it's not just at that next layer down of critical equipment, but it's at the facility level. Is facilities have already started, or many facilities and facility owners have started their journey. But I see massive growth and opportunities to improve on that facility level of predictive maintenance as well.
Understood. Virgil, I'm going to pose this next question to you. In your presentation, you touched on technical challenges associated with predictive maintenance. Can you expand more on those challenges?
We brought Ryan on this call so that he could get into the technical challenges, and I will tack into Ryan's answers next. But let's let Ryan go to the deep technical stuff, and I'll give the marketing perspective afterwards.
Fantastic.
That sounds good. I can definitely hop in. Yeah, thank you guys. So I just want to continue to talk about those major challenges and what I'm really seeing as the top ones that organizations are really faced with in terms of predictive maintenance. So just touching on the first one of the major challenges of predictive maintenance is too often organizations are forced to rely on outdated, incomplete, or inaccurate information to make decisions that result in inefficient system operations. So there's really a need for organizations to really solve the challenge of collecting and ingesting real-time data from all different types of sources into some kind of centralized data platform. And you must also consider low latency as a major decision variable for predictive maintenance as well, which really is the time window or time interval within which a decision needs to be made or an issue needs to be resolved, which must be as real-time as possible. So real-time data is really the basis for predictive maintenance systems. And when you're trying to predict machine or part failure ahead of time, it's really important that you have the latest information really down to the minute or second to have the most accurate forecasting and predictions. And then I also want to go back to the importance of that unified data platform. So another major challenge that we see organizations being faced with are siloed processes and the lack of a scalable, high-performance data analytics platform, which can really challenge the ability to shift from reactive maintenance to being more proactive and predictive. So ultimately, right, scalability is also important to consider, because as your data grows, you need to make sure that your analytics platform can grow with it without a reduction in overall performance. And also another major challenge I want to touch on is machine learning, right? So there's also a need for ML model speed and accuracy. So it's really important to have the ability to have those quality machine learning models so that you can easily train them to accurately spot those inefficiencies or delays using that real-time data that you're collecting. We also see the challenge with organizations that they may not have the talent in-house. They may not have in-house data scientists. So another challenges that we see is organizations might not know where to get those predictive models. So we see a challenge to actually figure out and hope that the data platform that they're choosing has those analytical models and ML as part of the solution. And just I think finally another challenge, a major challenge, is that organizations really are dealing with collecting data from all sorts of sources. That data can be structured, semi-structured, or completely unstructured. And so data complexity and data cleanliness is also really important to, understanding and extracting the right value from a predictive maintenance model. And so this is also another challenge that needs to be addressed early on when organizations are designing and implementing predictive analytics.
I'd like to add on to your skill set part there, Ryan. Sometimes just a chart's enough to be a predictive maintenance, right? But just creating a chart alone, right? Going from the raw data insights to get that chart or get that, isn't as straightforward for everyone, right? It involves knowing where the data is at, how it's stored, structured, kept, permissions. There's skills around the SQL, using machine learning algorithms, if you need to make it into a model as well. So just understanding how to create, those visualizations, and how to use a designer, right? Those are skills that people don't just have out of the box. And so, having a sort of supporting an environment where multiple skill sets can work together on the same data is why I showed that slide earlier. Where some people can do the visualization drag and drop if they need to for the quickness, and some people can write the sophisticated models as needed, and they can all work together to create one cohesive solution. So,
yeah.
That's a great point, Virgil. And I know how important data democratization and getting that access and people being able to work with the data in a user-friendly way can be for these types of initiatives. Phil, I'm going to move back to you. What are some lessons learned as companies explore and progress down their predictive maintenance journey? I'm really curious to hear your viewpoints on that, especially as a former field engineer.
Yeah, so maybe not necessarily a lesson per se. I guess it's a lesson throughout my career, and it's been ingrained in me since my first day in my career, is that every energy company that I've ever worked for or served has stated that every safety incident is preventable. And they'll say that on their website. They'll start off with their investor reports, just sharing how important safety is to their organizations. And having been a field engineer and have been exposed to hazardous scenarios. I 100% agree with this perspective. And I think predictive maintenance is going to be part of that journey to zero HSE incidents. When I started in the energy and resources, sector 25 years ago, there have been a lot of improvements along the lines of safety over the past 2.5 decades. And I see even more improvements in the coming years, in the coming decades. And I think a big contributing factor is going to be coming from predictive maintenance capabilities.
I'm glad you brought that point up, Phil. It didn't occur to me as somebody outside the space that predictive maintenance could play such a role with safety. Oftentimes I'm thinking, if the machine breaks down, the company can't produce this, or they can't deliver this, or connect people via the different cell towers. But it sounds like there's a lot more to the story.
Yeah, and that's not just in the energy sector. To share a personal story, a couple months ago, my father-in-law had a stroke, and we took him to the emergency room. And within 10 minutes, he was getting a CAT scan. What happens if that CAT scan is not operational, and you can't provide that imagery to a person? So it doesn't matter what industry you're in. Chances are, if you've got critical equipment, it has an impact on safety.
Sure, absolutely. No, that makes perfect sense. And, sometimes it's not just about, obviously we talk about unplanned downtime and rising operational costs, but it can be life or death too. Yeah. Absolutely. Next question, Phil. What are some considerations for the ideal team for this? Who are the key players? And, if there are skills gaps, where are they?
Yeah, I think one of the biggest sponsors of predictive maintenance programs are operational executives. I know the first call I received as a field engineer was when there was unplanned downtime for an important piece of equipment. I received a call from an executive within operations saying, "I need you to get out of here and fix this." Right? So operational executives are feeling the tip of the spear when something unplanned happens with their equipment that they're responsible for in their operations. The design engineers for the equipment, they're critical in building a predictive solution because they've designed that equipment. They understand every component and the purpose of every component in that equipment, every sensor that is designed in that equipment. They know what that sensor was designed in then for. So design engineers can really provide the acumen and design understanding to help those predictive models. Data scientists, to make sense of the vast amount of data that's coming in from all the different where those assets are installed, and helping build those predictive models, and getting an understanding of what data has predictive value and what data does not, to further improve those models. Supply chain people are important in that journey towards predictive maintenance. If you have manufacturers today that you really can't rely on them, they've got poor product quality issues, or they've got poor aftermarket field service quality issues, they may not be the strategic vendor that are ready to move along with you in your predictive maintenance journey. So, having a good understanding of vendors that you can rely on and that are seeking to build their capabilities and create a closer bond with you. Supply chain is an important role. IT, of course, is that, as you saw with the capabilities, the advanced analytic capabilities we talked about today, is that those capabilities not only are useful in predictive maintenance, but they're useful in other applications that need advanced, massive analytics, fast analytics, reliable predictions. And IT is needed to plug and connect it together into the IT architecture. And then just to kind of wrap up, I'm going to call out, all the field engineers out there in the world. And as a former field engineer, there was nothing more frustrating than getting called out on your kid's birthday, or getting called out on Thanksgiving Day, getting called out on New Year's Day, and missing some of those important days, and going out to the site because there was something that came up that you had to fix, and you get out to site and there's no issue found, or it's not as urgent that it needed to be, right? And so I think those people in the field that are turning wrenches, they can provide an important feedback loop to the quality of predictions that you're making, and whether whether it's something the organization can depend on to create positive business outcomes. I think they're a critical part of that team.
Absolutely. That makes perfect sense. Phil, how does value cascade through the value chain here?
Yeah, so we talked a lot of elements about the value, about reducing unplanned downtime and safety. But if you want to even bring it up a notch, I think it's about creating value alignment between asset owners of the equipment and the strategic their strategic vendors of manufacturers and service vendors. It's that alignment in the value creation that ecosystem is creating. Manufacturers, having worked for many of them, manufacturers often measure their business value and success in terms of units that go out the door and product quality and service quality. And all those are important, but they indirectly connect to the most valuable forms of value creation, asset uptime and safety and productivity. And so I think predictive maintenance is going to enable a direct connection between asset owners and their strategic vendors to create a direct impact on asset uptime and safety and those business goals, and really align on the value throughout the entire ecosystem. I think another area of value is that these manufacturers they want to elevate the relationship with their customers. They want to create that closer bond. They want to sell more than a widget, if you will. I hope I don't offend anybody that out there that manufactures a product and just saying widget. They want to be part of that value creation model. And by moving to a predictive maintenance service offering or adding that as part of your capabilities, it creates a new revenue generating model for those vendors and service providers. And then finally, I see securely connecting equipment performance data between asset owner and manufacturer. This is going to provide a new level of insights for manufacturers to innovate new products, to innovate new capabilities, to and enhance and aid and improve upon the predictability and performance of that. And so I think the innovation that's going to come from predictive maintenance is going to be phenomenal.
Understood. All right. I really like this next question. And Phil, I'm going to start with you, but I'd like to ask each of you this. What has you most excited for the future?
Yeah, I'm going to start off with an easy one, and it's just predictive maintenance in itself. It's not just the sensor data that has predictive value. There are many forms of data that can have predictive value, both structured and unstructured. It might be a drone video that's monitoring corrosion or some other form of asset integrity, satellite imagery, measuring vegetation growth, or completion of a work order. I think there's many forms of data out there that has predictive value. And second, just to kind of hit home again, is I'm excited about the innovation that will come from predictive maintenance. I think manufacturers are going to learn more about their equipment, gaining secure access to the information coming from that equipment that they never had before once it went outside and was shipped to their customers. I think by securely connecting equipment data between asset owners and vendors, it's just going to stem a whole new level of innovation that leads to better equipment, longer lasting equipment, and more reliable equipment predictions.
Absolutely. I could definitely see a ton of value there. Ryan, what has you most excited for the future?
Yeah, I think a trend I'm really excited about is I'm really seeing across, many analytical solutions, including our own right at OpenText, which is, trying to make those analytical platforms easier to use and more accessible by more personas within an organization. So as we've talked about, this trend has really exploded with AI that, allows more non-technical people to start to get, interacting with the analytics without having to write any code or without having to write any SQL. So as you mentioned earlier, Stephen, right, like this trend of democratizing analytics for an organization and, really reducing the complexity so that more people can ask those questions about their data using natural language, right, to AI. I think that's a really cool trend that I'm really excited about, and also that we're really focused on OpenText as well. So that's my answer.
Absolutely. Yeah, I see Gen AI being a huge boon in that area, definitely. Virgil, curious for your take on this.
Yeah, I guess I'm going to extend that a little bit further. Generative AI is definitely, like you said, the future, right? Is the future here now, right? Generative AI is, I think it's on us. Now it's not, the future is not too far away. People are using that today. Some of the complexities around conversational interfaces to specifically to BI is a little harder, right? So generative AI is really good at going and finding something you're looking for out of a chunk of text. Not so good about chunking all the numbers together and giving you back a good chart, right? And so I think that trend is improving, and we're creating something as well that gives you that conversational interface to BI, which allows you to get those answers back and ask those questions, and help with that data democratization, which sensor is failing, and being able to ask those questions directly and not waiting for somebody, not having bottlenecks of reports waiting for you to answer your question for somebody to get back to it, right? So it's about making fast decisions, being the key to being competitive, and the faster you get that data back, just by asking for it, I think the better. So generative AI for sure is the trend I would like to leave us with as well, but for sure that's our future, and it's here now. So.
Absolutely. And it still seems like, actually, I'd be curious for your take on this, Virgil. It still seems like there are going to be problems and opportunities that are best addressed with traditional BI. There are going to be things that are best addressed with, more advanced analytics. And then there are going to be things where AI makes sense. Is that kind of what you're envisioning for the future?
Sure. And, I think, and mostly, there's, ideally everything should be answered by, generative AI sooner or later, right? It's just that it's not as smart, yet, right? And so if you can ask a BI question and say, what do you think my chance of this machine breaking, and it can give you an answer without you having to go run a report or ask somebody, you would want it to, right? So, but for sure, you're going to have a hybrid solution for a long time, and the marriage of those two solutions is getting smarter and more clever, and how we prompt to ask that BI system to get the exact precise data back without hallucinations, I think is the challenge. But that's the challenge that's being addressed, I think, today.
Yeah, that is the billion-dollar challenge as well as opportunity, big opportunity. And yeah, I definitely agree with your point. If you can just ask the question and get the answer relatively easily, you're probably going to move in that direction. Okay. So to round things off today, just a few attendee questions. First question, I'm going to pose this to you, Virgil. How does OpenText differentiate itself from similar solutions focused on predictive maintenance?
Oh, right. Yeah. So, OpenText at the moment, this might actually be a better question for Ryan. I think some of the strength of our predictive maintenance solution is in the speed and the how fast we can do it, how efficient we can do things at the database level. And Ryan, you want to help me finish that answer?
Yeah, I can definitely talk more about what we're doing on OpenText to kind of solve a lot of the challenges we talked about earlier. And so mentioned earlier in this slides, right, we offer an analytical database product, which really offers that all-in-one platform for ingesting, transforming, cleaning, loading, and analyzing all your data in one unified data platform. And this product really supports easy integrations with any types of data from a lot of different sources, right? We really though focus with this product on mainly structured and semi-structured, but we also offer other products at OpenText are really strong with unstructured data as well. So we really have it all at OpenText when you're dealing with all different types of data and sources as well, where that data is coming from. And also just to mention, we have products like database that has integration with a lot of different PM reporting tools as well. So we really have a lot of integrations that allow our customers and people to make it a lot easier to understand the analytics and run analytics without having to write code. We offer a lot of great products or integrations with products that have that drag and drop user interface as well. But we also, as part of the analytical database, have the ability for more technical users to write SQL to create those questions and those analytics through code. We have a great Python library that allows people to also create predictive models. And this Python library actually works in the database. So actually bringing the predictive modeling into the database, which reduces the latency talked about earlier as well. So this really allows the data to be as real time as possible when you're training those models as well, which is really important. And also the core analytics database and our analytics database is highly scalable and flexible. So it's very it's the use cases, right, are for customers that are loading a lot of data and want answers to the analytical question back very quickly. And so our products are very highly performant, and we can run the analytical database on-prem in the cloud as well. So I'd say
absolutely. Yeah, and organizations like that choice to be able to deploy on-prem, cloud, et cetera. It might be a hybrid deployment. And it sounds like you are addressing different layers of the stack as well with the database, the analytics tools, the data visualization, which is really important. Okay, I've got 2 more questions for you today. And I think I'm going to give this to Phil to start off. If there's one thing you would really like our viewers today to walk away keeping in mind, what would that be?
Reimagine the current state. Is that if there's something that you want to do with information, and in this case predictive maintenance, the tools are available for you to make that happen. And OpenText, we're not here to sell you software. We want to help you create a business outcome. And if you've started that journey and need a strategic partner, if you haven't started that journey and you need a strategic partner, just know that OpenText is here to partner with you, to help you create those business outcomes and to reimagine what your information can do for you.
Absolutely. Okay, and one final question, and this is an important one. Where can organizations find more information about predictive maintenance solutions available through OpenText?
Yeah, so OpenText.com for sure has some information about the individual products that we listed here, or for sure contact us and we can get this predictive maintenance solution in front of your team if you want to learn more about it.
Fantastic. Well, I would like to give a big thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, Phil Schwarz, Industry Strategist for Energy and Resources at OpenText, Ryan Sickles, Lead Product Manager, Core Analytics Database at OpenText, and Virgil Dodson, Product Marketing Director, Analytics Cloud at OpenText. If you would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's broadcast. It will be archived and you will receive an email once the archive is posted. Thank you everyone for joining us today, and we hope to see you again soon.